Dear students, in this lecture, we are going to discuss about the stationary waves, which is a very important topic for the theory of oscillations. The point to remember while discussing the stationary wave is that stationary waves is not a pure wave, but it is a superposition of two waves traveling opposite to each other. In this lecture, we discuss the formation of stationary waves, their properties, and what will be the equation of the stationary wave when the medium is free or the medium is rigid. So, stationary waves are produced by superposition of two waves of equal amplitude and frequency traveling with the same speed in opposite direction. As shown in the figure below, two waves represented by green and blue lines travels in the opposite direction. Their superposition shown by the black line gives the resultant stationary wave. The, it is named so as it appears stationary in the medium. It travels in the form of node and antinode. So we see that there is an antinode in between two nodes or a node in between two antinodes. To discuss the properties of stationary waves, the first very important point is that the stationary waves are always produced in bounded medium. The medium must be bounded and no transfer of energy takes place in stationary wave because both the waves are similar to each other and travels in the opposite direction, so carries the equal energy in opposite direction. Therefore, the net transfer of energy is zero. It travels in the form of nodes and antinodes. All particles between two adjacent nodes are in same phase. We have to keep in our mind that the distance between two consecutive nodes and antinodes is lambda by 2. The amplitude of a stationary wave is 0 at node and maximum at antinode. Now, nodes are the position where the displacement is minimum, strain is maximum, and change in pressure and density are maximum. In between the nodes, we get antinodes. Antinodes are the point where the displacement has maximum amplitude, minimum strain, and change in pressure and density are minimum. So we see in the figure again that antinodes are the position with the maximum displacement while the nodes are the position with zero displacement or the minimum displacement, and the distance between two consecutive nodes is lambda by 2. So we see that all particles between two adjacent nodes, all antinodes are in same phase. The waveform in a stationary wave does not move through the medium. So as there is no energy, the net transfer of energy is zero or energy is not carried away from the source, the waveform appears stationary in the medium, therefore called stationary waves. The amplitude of a stationary wave varies from 0 at a node to maximum at an antinode and depends on position along the wave. So again in this figure we see that the position of node and antinodes remain fixed in the medium. Now to find out the equation of stationary wave, y1 equal to a sine 2 pi t upon capital T minus x upon lambda. Let this be the equation of a plane progressive wave with time period capital T and wavelength lambda. So the equation of reflected wave will be y2 equal to plus minus a sine 2 pi t upon t plus x upon lambda. It is plus x upon lambda because it is moving in the minus x direction. Plus minus a means plus sign is taken if the boundary of the medium is free, and minus sign is taken if the boundary of the medium be rigid. So we get the reflected wave as plus minus a sine 2 pi small t upon capital T plus x upon lambda. Let us, in first case, let us assume that the boundary of the medium is free. So we take the positive sign here y in the second equation, and y2 becomes plus a sine 2 pi t upon t plus x upon lambda. Using the superposition principle, the displacement of the resultant wave is given by y equal to y1 plus y2. We substitute the value of y1 and y2, and using the formula for the sin c plus sin d and cos minus theta equal to cos theta in the resultant wave we put. So we get the equation of stationary wave as y equal to 2a cos 2 pi x upon lambda sin 2 pi t upon capital T. Let us discuss the equation for the change in position and change in time. For the change in position, we take the amplitude as 2a cos 2 pi x upon lambda. If the amplitude of the resultant wave at given time t, it is equal to 2 pi cos 2 pi x upon lambda, the intensity will be as square of the amplitude is given by 4a square cos square 2 pi x upon lambda. If we have to find out the position of antinode where the intensity is maximum, for that cos square 2 pi x upon lambda should be plus 1, or cos 2 pi x upon lambda should be plus minus 1. So on solving this, we get x equal the values at 0 lambda by 2, lambda 3 lambda by 2, and so on. That means these points represent the position of antinodes, and at free ends an antinode is formed because at x equal to 0 we get an antinode. So we see that at free ends antinode is formed whenever the medium is free. Now to find out the position of nodes, as at the point of nodes the intensity remains minimum, so we must have cos square 2 pi x upon lambda equal to 0 or cos 2 pi x upon lambda equal to 0. So taking the general value of this, we get the position x equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on as the position of nodes. So we see that at free ends antinode is formed. The nodes and antinodes are formed alternatively at equal distances. The distance between any two consecutive node or antinode is lambda by 2, and if we have to find out the distance between a node and nearest antinode, it is lambda by 4 because at x equal to 0 node is antinode is formed, and at x equal to lambda by 4 node is formed. Now let us see the equation change with respect to time. If at given position x the amplitude a is given by a equal to 2a sine 2 pi t upon capital T. So the intensity is square of the amplitude equal to 4a square sine square 2 pi t upon t. Again solving it for the antinode where the intensity is maximum. For this sine square 2 pi t upon capital T should be 1. So on solving this, we again get at t equal to small t equal to t by 4, 3t by 4, 5t by 4, and so on. We get the position of antinodes. So each particle of the medium is in a position of maximum displacement twice in period of vibration at the point t by 4 and 3t by 4. If we have to find out the position of nodes for minimum intensity of wave, sine squared 2 pi t upon capital T equal to 0. It should be equal to 0, or sine 2 pi t upon capital T equal to 0. If we solve this, we find that at time t equal to 0 or t by 2 or t 3t by 2 and so on, we get the nodes. So these point represents node. Therefore, each particle of the medium passes its equilibrium position twice in each period. Equilibrium position means where the displacement is 0. So nodes as well as antinodes, in one period we get two nodes and two antinodes. Now let us discuss the second case when the boundary of the medium is rigid. In this case we take the negative sign here. So y2 equal to minus a sine 2 pi small t upon t plus x upon lambda. Again using the superposition principle, y equal to y1 plus y2, we get on solving this y equal to 2a sine minus 2 pi x upon lambda cos 2 pi t upon capital T as sine minus theta equal to minus sine theta. The resultant is, use the stationary wave as minus 2a sine 2 pi x upon lambda cos 2 pi t upon capital T. This is the equation of the stationary wave whenever the boundary of the medium be rigid. So again we explain the resultant wave similarly as in the case of free medium. The amplitude of the resultant wave at given time t is given by minus 2a sine 2 pi x upon lambda, or intensity of the wave will be square of the amplitude, that is 4a square sine square 2 pi x upon lambda. So to find the position of antinode, maximum intensity of wave is given by at point sine square 2 pi x upon lambda is equal to 1, or sine 2 pi x upon lambda equal to plus minus 1. On solving this, we get x equal at position x equal to lambda by 4, 3 lambda by 4, 5 lambda by 4 and so on. We get antinodes. So unlike a rigid boundary, here we get the first antinode at lambda by 4, while in that case we get the first antinode at 0. Now if we have to find the position of nodes for the where the intensity of the wave is minimum, the minimum value of the amplitude is when sine square 2 pi x upon lambda equal to 0 or sine 2 pi x upon lambda equal to 0. This happens when x equal to 0, lambda by 2, lambda 3 by lambda by 2 and so on. So we see that x equal to 0, an antinode is formed. So in case of the rigid medium, at free ends an antinode is formed. So a rigid ends an antinode is formed. At rigid end at nodes is formed. The nodes and antinodes are formed alternatively in equal distance, and like rigid free medium, here also the distance between two consecutive node and antinode is lambda by 2, and the distance between one node and one antinode is lambda by 4. So hope you understand the topic. Thank you. Thank you very much.